Declarative programming is a different approach to programming than some of the work we've been doing in this course already. It contrasts with imperative programming, where you describe what you want a computer to do. In declarative programming, you typically just describe the result you want to be produced, and the programming environment, the interpreter or libraries that you're using, figure out how to compute that result efficiently for you. Imperative programming often involves mutation for the purpose of computing a result. You would write code that would specifically say, go through each element, keep track of these temporary variables along the way in order to compute the maximum difference between two elements, or whatever it is that you're trying to compute. Because when you're programming imperatively, you have control over exactly what happens when, whether or not your program is computationally efficient is often determined by the code that you write. It's up to you to think about those concerns, and we've seen examples of that in this course, which has mostly been about programming in an imperative style. Object-oriented programming in particular is a useful way of organizing imperative programs. Where a lot of state is changing, the best way to think about mutation is through encapsulation into objects. That's much easier to reason about than just having a bunch of global variables that are changing all the time in a complex program. But why describe the details of how to do something when a computer could work that out for you? That's not a good use of time, and so declarative programming makes a lot of sense in certain contexts. Often in declarative programming, you're abstracting away the details of how memory is changing during computation. Instead, you have some language that describes the goal of the computation, and exactly what's happening in order to get you there is up to some library or module or interpreter or something like that that's doing the work. As a result, computational efficiency is often determined by the language design and the interpreter rather than the particular instructions that you're giving as the programmer. And often one of the goals of declarative programming is to make sure that efficient solutions happen automatically, even if the programmer doesn't think of them. And have we seen anything declarative yet? Well, I'd say we have. When you write a program that's just a bunch of functions in a functional programming style, oftentimes you are just describing the result of what you want to compute as a composition of a bunch of different functions. And what about programming languages? Well, I think lots of modern programming languages support both imperative styles and declarative styles. It really depends on exactly what kind of program you're writing and how you write it. So I wouldn't say that Python is an imperative language and Scheme is a declarative language. They're much too similar to have this kind of fundamental differentiation. But certainly the features of a programming language and the libraries that exist in that language do tend to nudge programmers toward one approach or the other, and so you should know that that distinction exists. And think about cases where, instead of just describing how to compute something, you could describe the result and have the computing environment work it out for you. Another way in which programming differs is by the language itself. There are some general-purpose languages that are designed to describe any computation, build any application, and then there are domain-specific languages that are designed to solve some particular class of problems. So, general-purpose languages include Python, Scheme, a handful of others that you've heard of that get used to build applications. These do differ in the programming styles that they tend to promote, and some language features really make it easier to build a particular kind of application than others. And this is not something really dig into in this course. But I think as you learn other programming languages, you'll start to see how some are a better fit for building large applications of one kind versus another. But domain-specific languages really are much more specialized. They include things like SQL, which manipulates tables of data, and we're going to learn about it in this course. HTML, which describes the contents of websites. CSS, or cascading style sheets, describe the presentation of a website, like the fonts and spacing and layout and that kind of thing. Regular expressions are a language for describing how to find patterns within strings. So each of these languages has a particular purpose. They are often declarative in character, because if all you have to do is describe what you want, instead of describing how to compute it, that makes life easier for the programmers. And since these are specific to particular problems, they often need to be used in conjunction with general-purpose languages in order to build a whole application. And so many general-purpose languages have a way to also write some of your program in a domain-specific language, and that's often the most efficient way to get something done, which means that you end up learning both general-purpose languages and domain-specific languages in order to build applications and get things done in the world.